In section 3.4 today, we are going to look at basically ways to be able to sketch a graph, but a pretty accurate graph of something harder than just like a cubic or x squared. Okay, so we've got to look at these concepts, and we call them bounce, wiggle, cross. Okay, so a bounce in a graph, what is that? That's when the x-intercept of a polynomial factor is raised to an even degree or an even power. Okay, and what happens is the function is tangent to the x-axis at this root. I like to describe it with two pictures. Here's what's happening. Here's what we're talking about. If it has an even degree, then it's either going to, and if you think about what tangent meant in geometry, just barely touch it, I'm going to call that a like bounce off the floor. Okay, think of it as like a ball. It's coming in, it's bouncing off the floor. Going down and coming back up. Okay, or likewise, since it again has to be about the x-intercept, then maybe it's coming up and bouncing off the ceiling and coming back down. Okay, so I think of this one as bounce off the ceiling. And all we're trying to get down is the basic shape, like at that point, what's happening. Okay, so the next one, what's a wiggle? That happens when the x-intercept of a polynomial factor is raised to an odd degree greater than 1. Okay, an odd degree greater than 1. And for this one, the function flattens out at this point on the graph. So let's say, for instance, I'll use a different color so you can see. Let's say at this point, it's going to flatten out that way. Okay, and I know it comes from above the x-axis through that flattened out point and goes below the x-axis. Well, think about this. There's only one way this could curve. That's what we're talking about, is the curvature. Okay, it's what we call concavity. There's only one way this could curve to make a nice, smooth polynomial function graph. Okay, remember, they're nice and smooth. For instance, don't draw this because I'm going to erase it. But if I started down like this, there's no way for me to connect to that flat part without having a sharp corner. Okay, so we do not connect. I sometimes call that the right side of a frowny face. Okay, that's also called concave down, just to use some of the words that you'll use in calculus. But if we draw it as concave up, which would be the left side of a smiley face, it now comes into that flat part perfectly smooth. Now leaving it, same thing, how am I going to go below, right? Because we actually cross the x-axis, but it's got to flatten out at that point. So now I have to go below the x-axis. Well, the only way for me, sorry about that, the only way for me to go from the flat part below the x-axis and be a nice smooth curve is to curve in that direction, which is called concave down. Okay, now sometimes it's hard on some of these harder problems where these all have a bounce, a wiggle, and a cross, okay, or more than one. So it's hard to tell your wiggles sometimes. So just point to it and write wiggle. Okay, I'm only going to ask you to label wiggles. Some teachers might ask you to put a B with the bounces, a W with the wiggles, and a C with the cross that we've got coming up. Right now, for me, you can just label wiggles. Okay, same thing. Now let's say over here, let's say you know it has to be flattening out at this point, but you also know for some reason it's got to be coming up from left to right. Okay, so it's got to be below the x-axis. Again, notice I can't curve that way if I'm coming up and meet that without being a sharp corner. Okay, so I can't be concave up. I would have to be this curvature of concave down, or the left side of a frowny face. Flatten out, and the only way that I can come out of that and be a nice smooth curve is to be concave up. Okay, so again, you're going to point to that. You're going to tell me it's a wiggle so that I know you're trying to change the concavity, the curvature, whatever you want to call it. And then once again, I'm just going to emphasize that you're always, I won't ask you to do it, you just have to always label wiggles for homeworks and quizzes. All right, and last but not least, what is a cross? So a cross happens when the x-intercept of a polynomial factor is raised to the first power. Okay, so now we've covered them all. Odd, that's not 1, even, and this one is to the first power. So, I mean, just think about what a line does, right, guys? It just crosses, it just goes straight through, it doesn't flatten out or anything. So, if you were going up from left to right and crossing through something, it's just at that point, it might look like that, okay? If we know it's not a line, though, it's probably going to have some curvature to it. So, again, it might be something where you're just coming up and crossing straight through. Okay, depends on what it's connected to. So if it's going down, then obviously if it's a line, it just crosses like that. But if it was more of a curve, it might be doing something like that. Okay, so we're just saying it just goes right through it. It just crosses right through it. Okay. All right, so let's review real quickly. Draw me a quick what y equals x to the first, x to the second, x cubed, x to the fourth, x to the fifth, x to the sixth, and x to the seventh parent graphs look like. Okay, because we're talking about the end behavior. Remember, 1 should look like this, parabola, 2 should look like that, cubic should look like this. Remember, we're focusing on the arrows. Okay, notice all the ones on the right side are rising to the right, and the ones on the left are alternating, right? The first one is falling, the second one is rising, the third one is falling to the left. If you're standing in the middle, that's our new wording. Okay, so on x to the fourth, then the arrows both better be going up. X to the fifth, first one should be going down. Okay, x to the sixth better both be going up. X to the seventh. I think you've got enough of the pattern. Okay, so that's what we're talking about. All right, so now putting everything together, what you know about end behavior and what we just taught you about bounce, wiggle, cross. If I ask you to make a rough sketch of the graph of the following polynomials, okay, we'll do 3 of these. Here's the very first thing you should look at. Decide if you were to multiply this out, which you are not going to do. But decide if you were to multiply this entire thing out, what the highest power would be, because the highest power wins out. That's what rules your end behavior. So here's the first thing I decide for myself. I notice the power here is 2. So if I multiplied out just this part, it would be squared. Times this part, which is to the first, would now make it cubic. Times this part multiplied out would give you a cubic, times another cubic would be x to the sixth. So ultimately, really all I'm doing when I look at this, guys, is I'm just adding all the exponents. Okay, I'm saying 2 plus 1 plus 3. That's going to give me an x to the sixth. Okay, if you multiplied those out, the highest power would be x to the sixth. The other thing I look at is this right here. Is it positive or negative, right? Because we have our parent graphs memorized with a being positive, that number in the front. So to me, I write that this is a positive x to the sixth graph. And immediately in my mind, because I have them memorized, I know for an x to the sixth graph, my end behavior has the arrows both going up. That's all I draw for myself. And then I just go across and I say, well, at x equals -3, right? Because all I'm doing is taking this and saying, where would that x-intercept be? So I'm just solving it. That's all I'm doing. Okay, so at -3, I would have a, it's an even power. That makes it a bounce. Okay, I like to kind of try to put them in order for the graph. So -2 is going to be next, and then 5. At -2, well, since this x plus 2, all I did was solve this. Since that x plus 2 is to a odd power, that makes it a wiggle. And last but not least, if I take the x minus 5 equals 0 and solve, that's why I said it's at 5. At 5, I have a, well, it's to the first power, which means I have a cross. Okay, now as far as the work I expect to see from you, I don't need any of these once you understand that part. I just need exactly what I've got written there. Okay, so I at least want to see your thinking. And then the sketch part of this is as follows. We'll label at the end, okay? But for right now, I notice based on the curvature, you can do some experimenting and thinking, guys, but I know I've got to do something here at -3, here at -2, and here at 5. Okay, so if the arrows are going to end like they were drawn right here, okay, then I must be coming down to this bounce. Okay, so do the best you can with your curvature. I am going to bounce off at -3 and start back up. Okay, nice smooth curve. Now, I know it's tough to fit, so just do the best you can. To go to -2 and have that be a wiggle, that means to me I have to flatten out through here. Keep in mind it's got to be a nice smooth curve. So to do that, I have to come up and back down and flatten out somehow and go this way. Okay. I know my points are a little bit thick. It makes it look like it's double, but just make sure that you're getting it nice and smooth and flattened out. Okay. And then between -2 to 5, well, at 5, I've got a cross. So it means I can't go back up or across that x-axis, guys, until I get to 5. All right, well then, I probably want to make this still look like a function. So anyway, it's coming out, it's going down, it's got to flatten out, and end with my arrow looking that way. Okay. All right, so I redrew it for you so it looks more like a smooth curve. Let's kind of point out some things. So to get full credit, let's at least do this part first, and then we'll chat again to make sure that you kind of understand where this is coming from. So yes, I just need you to label the x values that were included, the -3, the -2, the 5, and we said we will always label a wiggle. So I just need you to go ahead and point to that one and say it's a wiggle. Okay, that would be full credit. Now let's go highlight the points and what we're talking about. Okay, at the start we decided this was a positive x to the 6th, so we knew the left arrow had to be going up. That's that part. I also knew the right arrow had to be going up. That's this part. When I first look at my values of -3, -2, and 5, I noticed the wiggle of -2, and I just put myself a little dash, okay, meaning it's got to flatten out. And at -3 and -5, I just put a dot. And then I did the best I could with what I know about a bounce, wiggle, and cross to make it look like a nice, smooth curve. Okay, and that's what changes your curvature. Okay. Okay. Let's try it again. If you want to try it yourself, go for it. Turn the video off and come back. All right, to me, this is a Well, 1 plus 3 plus 2 is 6 again, and there's a negative in front. So to me, the very first piece of information I'm writing down for myself is that this is a negative x to the 6th graph. I've got positive x to the 6th graph memorized that both arrows are up, so negative means they're both going down, and they would be going in that direction to be smooth. Okay, I'm going to have x values in this at 1, -2, and 3. So if I just kind of put them in order for the graph, kind of helps me a little bit. -2, 1, and 3. So at -2, since it's to a odd power, will be a wiggle. 1, since it's to the first, will be a cross. And 3, since it is the power is even, it's going to be a bounce. And guys, also don't think that all of them have to be included. Like, it doesn't have to include a bounce, wiggle, and a cross, ever. Likewise, you could have more than one. Okay, you could have multiple of these. All right, so I just want to make sure you're not making that assumption. So notice, based on the arrows, I've got to do a wiggle through -2. So -2, I'm just going to put a little flat dash for myself to remind myself. Something through 1 and something at 3. Okay, to have that sort of arrow on the left, okay, then I've got to be coming up to -2, and I've got to wiggle through that. All right, the only way to connect to that and be smooth is to come this way and then this way. All right, now between -2 and 1, you may not cross the x-axis again, okay? Not until you get to 1. So to cross at 1 and still be a nice smooth curve, all right, it's just going to come back down, cross, and just keep going. Okay. And now again, between 1 and 3, you may not cross the x-axis, not until you get to 3. Okay. And at 3, it's got to bounce. Well, since it's below the x-axis, it's going to have to bounce off the ceiling. And I also need to end with that right arrow going in the same direction. So the only way to curve and be nice and smooth is to come up, bounce off the ceiling, and go back down. Okay. I will clean it up one more time for you and then point out stuff. All right, so there you go. Now it looks like a more nice, smooth curve, okay, that I just can't do on the smartboard by picking up the finger. So anyway, there's your nice, smooth curve. To get full credit, you need to label our x values. So here's our -2, our 1, and our 3. And you also need to label the wiggle. So you're just pointing to that and telling me that is your wiggle. Notice the arrows on the graphs because they go on forever. And that would be it. Okay. All right, let's try one more. See what you can do with this one. And then come back and join me. All right, first thing I'm noticing, adding all the powers. 3, 1, 2, and 1. Looks like this is going to be an x to the 7th. And also noticing in the front, this is a positive, right? Not a negative. So it's going to be what I have memorized for a positive x to the 7th graph. I know the left arrow should be going this way. The right arrow should be going that way. Connecting them with our x values, which from above would be -6, -2, +2, and 5, just so they're in order from left to right. At -6, that's raised to the first, so across. The -2 is raised to the second power. So that is a bounce. The 2 is raised to what? An odd power. Okay, so that'll be a wiggle. And the 5 is raised to the first power, which again means it will be a cross. Okay, so here's 6, -6, -2. 2 is a wiggle, so I'll just try to make a flat dash, and 5 is a cross. Okay, so again, combining the arrows and what I know about the end behavior, I must be coming up to the -6. Okay, so coming up to the -6 and making it a cross and also a curve, right? Because it's not a line. I'm just going to go like that for a minute. Between -6 and -2, I cannot cross the x-axis again. Okay, I know that I need to do whatever's going to happen so that at -2 it can bounce. Well, since I'm above the x-axis, it's going to bounce off the floor, is my thinking. Okay, so it's coming up, bouncing off the floor, going back up. Between -2 and 2, it cannot cross the x-axis, so I've got to go from that bounce into a wiggle at 2. All right, so that means to me, it's going to have to go up, come down and flatten out, and do that. Once again, between 2 and 5, it cannot cross the x-axis until you get to 5. And I'm supposed to figure out how to go from a wiggle to a cross and still be a nice smooth curve. So I'm going to have to turn back around, cross through that, and end with the arrow the way I expected it. Okay. So once again, I will clean it up. All right, so cleaned up so it looks like a better, more smooth curve. There we are. Remember the requirements. You got to have the arrows on the end because it does go on forever. You need to label the x values that we used in this problem, -6, -2, 2, and 5, and you need to point to any wiggles so that I know you're trying to flatten that out. Okay, and that's it. I guess at this point, you no longer need a calculator ever because you're experts. You know how to draw everything, right? Just kidding. But get that practice, guys. That will give you a good rough sketch of what's happening. Okay? Good luck.